I'm going to go over, so last week we went over VOR alpha. Right? VOR alpha brownfield. We'll review that once today, and then I'll review it right off the bat. I'll go over the 5 major sections. We'll go over it fairly rapidly. And that's a non-precision approach. The dash alpha means there's only circle to land minima published, i.e. The approach itself, if you're following the instruments in, it doesn't lead you off into a position in which a landing can be made. Circle to land only. I'll explain that more as we start to get more into it. Today, so non-precision approach, dash alpha, circle to land, minimums published only. It doesn't lead you in a position to directly align or be aligned with the runway to land. And that's not 100% accurate. You'll understand why I said that later. But just in a position that you're not readily to land when you're perfectly aligned with the runway. Okay, circle land only published. Non-precision approach. A precision approach has to be, the signal has to be emitted by VHF. That's huge. So a precision approach, the signal has to be emitted by VHF. That's in accordance with ICAO Annex 10. Doesn't matter. That's like, okay, great. But it's going to show something when we start looking at other approaches. And I'll explain it why, and I'll give a little bit of a background on it. It used to be stated that a precision approach was an approach that gave both lateral, left to right, and vertical guidance. That used to be considered a precision approach. But then all of a sudden, we had this thing called the Global Navigation Satellite System, GPS based, and then we had the advent of this thing called WAAS, Wide Area Augmentation System. Very basically put, it is a setting of reference stations over a very large area. Let's just give an example, like from California all the way up to Alaska on the western side. And all those reference stations know their exact location. They would take the information that was given by satellite observation, latitude, longitude coordinate, but the reference station know exactly where they're at, and they'll say, hey, you told me I was at this position, but you're a little bit off, so I'm gonna send a master station the corrections. That master station is going to relay the corrections to a geostationary satellite. The rest of the satellites are in orbit. And we're going to send that information corrected back to the airplane via satellite. That's WAAS, Wide Area Augmentation System. Over a wide area, the GPS information gets augmented and or corrected, and that corrected signal gets sent back to the airplane to make everything tighter. i.e. when your cell phone says, turn on Wi-Fi to increase position accuracy. Well, that's essentially what WAAS is doing with satellite. That being said, since there is a geostationary, all the other satellites are in orbit, right? And sometimes when they're in orbit, they go onto a side of the Earth where we can't see them, therefore they can't give the signal. The geostationary satellite's always hanging out in the same position. It's coincident with the movement or the orbit of the Earth, so it doesn't move. Because of that, it can also give vertical guidance. It can triangulate in a vertical parameter. Therefore, with WAAS, we can get satellite-based approaches that have vertical guidance. Most of them are not considered, all except for one, are not considered to be a quote-unquote precision approach because the signal is not received by the aircraft via VHF. And those approaches are called APV, approaches with vertical guidance. Basically, it came to this. The FAA is like, cool, we've got all these approaches, and the ones with vertical guidance, we're gonna call them precision approaches. But in accordance with International Civil Aviation Organization, any signal that is for a precision approach has to be VHF, ground-based radio waves. And then they're like, cool, we have approaches now that have vertical guidance, but they don't have ground-based radio waves giving the signal. What do we do? Let's just name them something different, and we're going to call them APVs instead. approach with vertical guidance because they didn't know what to do with it because there was a rule that said, no, you can't have satellite systems precision. Today, we're going to talk about the ILS, which is precision. Cool, go for it.
Are the service stations ground-based or they're the orbit?
The reference stations
The
are
reference stations.
ground-based.
Okay.
Cool. And I'll show pictures of it. So, that being said, let me put it on display, go over the VOR alpha. Before the VOR alpha, though, I'll show a picture of the WAS. We're going to go over it again. I'll show a picture of the WAS just to make things a little bit more clear. And then we'll take a break. And then next week is spring break. Don't show up to class. It doesn't fail every semester. We're Dave Kirk. Next week, there's no class. Are we on the same page now? Cool. The following week will be your midterm, as long as everyone agrees. So that being said, VOR alpha, I'll go over WAS first. I'm going to talk about the ILS. We'll go over an ILS as far as an approach plate is concerned. We'll take a break, and then we'll go over all of the midterm questions again. Good? And we'll do like a question answer period on it. Okay, that's the plan. WAS. So here's WAS. WAS is an extremely accurate navigation system developed for civilian aviation. Our Department of Defense know that. Our DoD is in control of our GPS. They can turn a switch on and off. Okay, so I think I asked you guys a question at some point. Who's in control of GPS? DoD. Before WAS, the U.S. National Airspace System did not have the potential to provide horizontal and vertical navigation for approach operations for all users at all locations. I just went over that. But with WAS, it has the ability to give vertical information, but again, not considered precision because of the fact that it doesn't fall in accordance with ICAO Annex 10, saying for a precision approach to be labeled as precision, the signal has to be met or received via VHF. There is a GPS approach that does do that, and that's LAWS, but we're not going to get into that. Local area augmentation system. Here's the WAS system. You find a good picture that kind of satisfies it all. So, GPS satellites in orbit. It's called the constellation. They're going around the Earth. At some point, this thing's going to be on the backside where we can't see it. So it's not going to help us at all, right? So these are in orbit. The Earth is spinning. These things are spinning. At some point, any number of these satellites are not within line of sight, and GPS requires line of sight. Good? That makes sense? Like when Houston was talking to the moon, and they couldn't talk to the astronauts for a period of time because they were on the dark side. But then when they came around and had line of sight, they can talk to them, if that story is even true. WAS. So here are the wide area reference stations, right? All the little yellow dots. So it's over a wide area. Let's just call this one the western seaboard, the eastern seaboard, because there's different master stations. That's what these guys are. Wide area master stations. That's what this is, that's what that is. So this master station is inclusive of everything on the West Coast. These are all new. These ones are 2B. Oh no, those are international ones. This is a little bit different picture, but international wide area reference stations. You have your orbital satellites, but then you have your geostationary satellites, i.e. this satellite is always here. It orbits at the same rate as yours, so it's always hanging out. The other ones aren't. What happens is the wide area reference stations know their exact latitude, longitude coordinates. They're pre-programmed in. We know our exact position, right? 32.117.343 by 117.50.668. The North American datum, NAD. So that being said, these stations receive a signal and they send their exact location and what they received as a location to the master station. The master station says, wait a second, that GPS satellite told that station, I'm just gonna give a random number, it said it was at 33,117.545 when it's actually 32,117.545. So it was off. The master station says, whoa, we need to correct that. That's the augmentation part. It now sends the corrected signal to the WAS satellite saying, hey, you correct this guy. Because this guy's further out, it's just a time speed distance calculation and there's some issues. This guy says, okay, I'm gonna send now the corrected signal, which is more accurate, back to the airplane. So now the airplane, instead of having like 20 meters of frame of reference, has like 2 meters frame of reference. Some now even down to 1 meter frame of reference, some even less. Okay, so 6 feet is pretty accurate, 2 meters. So it's correcting that signal, utilizing all these stations that know exactly where they're at, wide area reference stations. They send it to the master station. The master station sends a signal via the ground uplink station to the satellite. The satellite resends the signal to the airplane saying, hey, here's your corrected signal, WAS. Cool? A review of this one. Key takeaways. 5 sections exclusive of the margin identification. 5 sections, this is just review, exclusive of the margin identification. The margin identification is everything on the outside. Key points on the margin identification are the dates of validity. This one's only valid for a couple more days, and it's going to switch. Julian calendar date. There's been a change on the approach plate, if you will, the IAP, the instrument approach procedure. There's been a change on the approach plate, but it didn't affect the change didn't affect the procedure itself. The procedural change is found under the amendment date down in the lower left corner, 20th of June. There. The FAA's reference, the type of approach, airport, city-state, city-state, and then down in the bottom in the middle, latitude, longitude coordinates. Margin identification. The 5 sections. What's this one called? Pilot briefing. Plan view, the overall plan. The overall plan. We're not going to do this again.
I can't hear you because all the loud noises out there.
Profile view. Minimums. Airport diagram. Okay, the 5 key sections. In the what's it called again? Pilot briefing section. Good. This is the primary nav aid. Why is it underlined? No voice capabilities. You can't talk to anyone through it. No voice capabilities. The primary nav aid frequency is going to be associated with the bold box. This box is bolder than that box. FAA's verbiage for the rapid identification of. Final approach course, the course found inside the final approach fix. Runway data or airport data, non-standard takeoff, non-standard alternate minimums, pilot notes, missed approach procedure, and all the frequencies of use in the order of use. The dark box around this identifies for the rapid identification of the fact that there is a towered airport. The tower is part-time. Pilot-controlled lighting. You could also identify a part-time tower because the tower frequency reverts to common traffic advisory frequency. And that's kind of the key points of the pilot briefing section. There was a question.
I'm sorry, what was the box?
What's that?
The box
Which one?
in the middle, what does it indicate?
This one?
Yeah.
If there's that darker box identified here, it's for the rapid identification of the fact that there's a tower at the airport. Good? Towered airport. Not all airports have a tower, therefore not all have that dark box there. Plan view. The biggest, baddest, boldest mark is the highest quote-unquote threat. That's the highest obstacle depicted. Good? There's 3 subsets of lines. This has 2 as far as depth of color. There's thin, thicker, and then thickest. The thickest line is the IIP itself, is the procedure. The procedure begins at the IAF. What's IAF stand for? Initial approach fix. It comes in this case, not all have, but this does, an IF, intermediate fix, and then it will end where those little dashed lines start, which is the missed approach procedure, and then in this case also shows the missed approach hold. So that's the plan view. MSA values, what's MSA stand for? Minimum. If you ever have a doubt with anything in aviation, just recognize what's the safest thing. Like if you're on a check ride and the pilot examiner says, well, why'd you do that? Well, that's the safest thing to do. Okay, then you move on. Right, the whole idea of the systems mitigate risk. Assessing the mitigation of risk means that you're evaluating what's the safest thing to do. It shows the airport, it shows terrain, it shows water, it shows land, right? It shows DME fixes. It shows airways, not airways, I'm sorry, it shows radials. It shows VORs, it shows altitudes. That's the plan view. In this case, the plan view starts at the IAF. It'll be at altitude, a minimum altitude of 4,000 feet from Mission Bay on a 076 radial for 10.7 miles to Hale, which is found on the 336 radial of Pogie at 10.3 miles. Southbound 156 down to 2,400 feet for 6.1 miles to Findlay at 4.2. No altitude listed inside Findlay, so that's the final approach fix. Coming down, it also shows Zeklu, but there is no cross radial to identify Zeklu, i.e. you couldn't use 2 VORs to triangulate it. DME would be required for that. Plan. Profile. It just shows the flight in with step down fixes. 4,000 at Hale, stepping down to 2,400. What's the Maltese cross identify? For a, what type of approach? FAF or a non-precision approach. FA, go for it.
While we're on that, is there a reason why some of these approaches have the IF and the FAF are the same and some are not?
Yeah, it's just the way the approach is designed. Like Oceanside has the IAF and the FAF as the same. Just the way the approach was designed. Inside, so that's a step down fix. Coming down to Zeklu, that's a step down fix. It's got split minimums. This one's kind of interesting because if you have the ability to identify Zeklu, you can come down to 1140. 1140 is the MD. Star tells you the location of the rotating beacon. It tells you the height of the tower, MSL. It tells you any improved surfaces, if there's any like closures, like in this case, it's hard to see from back there, but these are all X's, showing that those taxiways are closed. And then it gives you runway lighting, like runway end identifier lights for runway 26 right, runway end identifier lights for runway 8 left, which are pilot controlled, PCL. A MERL, medium intensity runway lighting for runway 8 right, 26 left, pilot controlled, and a high intensity runway lighting for 8 left, 26 right, pilot controlled. That's the same standardized form for all instrument approach procedures. Good? Questions? Go for it.
For pilot controlled lighting, is the frequency just the CTAP?
Yeah. Unless it's denoted as different.
And how do you do that with CTAP? How do you turn the lights on?
5 clicks to bring them on.
Oh, sorry.
3, 5, 7. Let me show you this ILS thing now. ILS is a precision approach. ILS stands for Instrument Landing System. There's different categories, 1, 2, and 3. There's different subsets and categories. We'll discuss those later. What we're going to look at right now is a category 1 ILS. Okay? Some standards for a category 1 ILS. The standard, not MDA, minimum descent altitude. When you have a vertical guidance, it's considered DA, decision altitude. The standard decision altitude is 200 feet above the ground. That's the let off.
Category 1.
Category 1. Category 1 standard decision altitude is 200 feet above the ground. If you were to call that the height, AGL, it would be considered decision height. So if I'm at an airport, and the airport's 400 feet, MSL, standardized DA would be 600 because it's 200 feet above ground. DH would be considered 200 feet above the ground, decision height, right? Not all are standard, like we're gonna look at right now. Go for it.
You said category 1 is 200 feet above ground.
Above ground, the standard position where you have to make a decision. That's the Mr. Broach point.
Is it separated in categories? Like category 1, 2, 3, 4, 5?
Yes.
Okay.
1, 2, and 3.
1, 2, and 3. So above the airport at 600 would be 3?
Let's not get into that one
Okay.
yet. Let's not, like, I'll tell you this. A category 3C approach lays you off on the ground. You could have 0 visibility and the airplane touches the ground. That's 3C. There are no minimums. Standard minimum for a category 1 is 200 AGL, which would be considered DH, decision height of 200 feet. Okay? Decision altitude, well, you're gonna add 200 to whatever the MSL value is, right? Let me just show you this thing, I'll describe it in a second. Trying to look at the picture that's in the AIM right here. That's pretty clear. Here's the components of an ILS. Per the AIM, let me read the descriptor of an ILS. Here it is. Here's the description of the ILS per the AIM. The ILS is designed to provide an approach path for exact alignment and descent of an aircraft on final approach to a runway. Okay, that's the design. Alignment and vertical guidance. The basic components of an ILS are, they give 3 things. I'm gonna give you their 3 things and I'm gonna give you what I like to describe it as, okay? Theirs are guidance information, and you're gonna have to know these. So the system may be divided functionally into 3 parts. Number 1 is guidance information. So the ILS gives you guidance information based on left-right guidance, lateral guidance, which is considered to be the localizer. Okay, the localizer is left-right guidance.
please.
Left-right guidance, which is considered to be the localizer with a Z, L-O-C-A-L-I-Z-E-R. It also gives vertical guidance, which is considered to be what's called the glide slope. I like to break those up into two parts. I like to say the localizer has 4 parts. One's left and right guidance called the localizer. 2 is vertical guidance called the glide slope. And you'll see why down the road. It goes down to inoperative components of the system. But the FAA defines it as 3 parts: localizer and glide slope for guidance. Left and right, up and down. Range information. Distance, which is distance from the airport. It used to be on a system called marker beacons, outer, middle, and inner markers. We don't use that system anymore. That's gone away for a multitude of reasons. So if you ever see like on the ICS intercom system of an airplane, there's like a blue O, amber M, and a white I. Those are OMI, outer, middle, and inner markers. That's used for the range information on an ILS. It's so to the point where it's not even taught in the ACS anymore. We don't really use markers. What we now use is the possibility of 3 different things. Most likely is going to be GPS. GPS will give us our range information, waypoint to waypoint. So GPS can give our distances, range, or a DME, distance measuring equipment, which can give us our range, or radar identification of fixes along the path, which would also be a range, i.e. radar control can say, okay, you are now over this fix. Okay, now you're over this fix. Okay, now you are over this fix. It would be like me if I was talking to my buddy, okay, you're 1 mile from my house. You're a half a mile from my house. You're a quarter mile from my house. Okay, that's my driveway. Good? And then the last component, so guidance information up, down, left, and right. Range information in the form of the old form, marker beacons, but today GPS or DME, and then also radar. And then the last source of information is visual information, which would constitute an ALS, approach lighting system. ALS, approach lighting system. They give you information that may be substitute for markers, compass locators, precision approach radar, airport surveillance radar, all these different things. We're not going to get into them right now. Then the localizer. The localizer transmits, operates on one of 40 ILS channels. You don't need to be that detailed. Nobody's going to ask you how many channels are there for an ILS. But just to let you know, within the frequency range, here's the frequency range for it, 108.1 to 111.95. Something that's interesting is all of ILS frequencies, their decimal number, they're odd. So you're not going to find decimal 6.5. You'll find decimal 7.5, decimal 9.5, right, and so forth. So that's just an interesting note. Signal provides the pilot with course guidance to the runway center line. So an ILS gets you on the center line. The approach course of the localizer is called the front course and is used with other functioning parts, glide slope, marker beacons, or range information, etc. The localizer is transmitted at the far end of the runway. It's adjusted for a course width, important, 700 feet, full scale left to right at the end of the runway. So if you're getting guidance by your needles, the far deflection of your needle, either left or right, you're all the way off, but still getting a little bit of guidance. Your needles are still working. Maximum deflection to either side of the runway center line is 350 feet. So it's 700 feet at the threshold, 350 either side. Good? Again, I'll explain all this in a second as we look at it. There's also inherently, the way this signal works, just picture like a laser pointer. Here's your runway. If this is runway 28, the localizer array is located at the end of the runway, which constitutes of a bunch of antennas. The antennas look kind of like a T if viewed from the side. They emit a signal that comes off in that direction like that. The total course width at the end of the runway to either side is 350 feet to either side, being 700 feet total. Oops, 700 feet total. But an inherent design of the localizer antenna is this is the primary course or the front course. It's kind of like if you had a flashlight that has a hole on both ends, and that's just the way the flashlight was designed. It also emits a course going that way, and that's called the back course.
Is there a reason why it's set at the departure on the runway and not the departure?
What do you mean?
Well, as in why wouldn't you have the localizer transmitter at the approach?
To be able to give you that 700-foot width, because if it was emanated from here, this way, things would get pretty dicey for the pilot as you get really close. The needle's gonna go crazy on you really fast. And there'll be no course width. Good? Let me show you a picture of what it looks like. Go to Google Maps, and I'll just show you, for example, the localizer antenna at Montgomery Field. Here's Montgomery Field. I'm gonna go to the satellite. I'm gonna zoom in on it. Here's runway 28. That's runway 28. Down at the end of runway 28, there's this little area that's got that array right there.
These are like battleship guns. There you go, laser beams.
Yeah, they shoot at you when you drive the fuel truck onto the runway.
Okay, yeah.
Are we done? So, this is the localizer array down here. This is the antenna that's emit out a signal, hence the reason why they have this clearway so nothing's in the way of the transmission. Good? If you look at it from the side, I'm gonna see if I can do this. Why doesn't it like me to select that? I think I have to do something here.
It's probably not a good idea.
Because you probably still would have the bin, so
What's that?
you can try selecting the street to the left of it. You can see it just like turn your.
So smart, Ben.
Right.
Sometimes. That's the antenna.
The battleship.
Those are Ben's battleship guns. Shoot you down as you approach the runway.
Now no one will forget.
Okay, so that's the localizer array. It transmits down the runway. It transmits down the runway, and then it also inherently has a view that goes in the opposite direction. So the primary course for this one is guidance for runway 28. It's guidance for runway 28. The opposing guidance does give a signal that goes on the opposite direction, which is considered to be the back course. Okay? Has anyone ever wondered, go for it.
Are there ever any instances where the back course is used?
Yes, and that would be a back course approach. We'll get into that one later, but you can use that. Has anyone ever wondered why in San Diego International, when the ceiling is really low, the airplanes come from the west and they land out to the east?
Parking structure?
Because the ILS has lower minimums, it has the lowest minimums, and they only have an ILS for runway 9. It's the only way that they can get aircraft down below low cloud decks to arrive. And yes, I heard comments about parking structures, but also all of downtown buildings. San Diego's a sketchy place to land. I mean, when you're coming into land here, you look out of the side and you're like lower than the buildings. And the ILS guarantees clearance from obstacles for that entire path. So if you're coming from the east to land to the west, they can't give an ILS signal. They can only give left and right signal, not up and down signal.
So every approach is visual, is it? When you go
No, they have a localizer, they have a GPS approach, but they don't really have a vertical guidance as far as VHF vertical guidance coming from the east to the west.
And in that sense, you're judging it visually, your vertical as well.
Sort of, or you're flying down by step downs.
So the city construction needs to take in mind that there's a whole localizer kind of zone that they can't build up to.
Say that again?
Like construction in downtown needs to know that there's like a kind of a localizer zone that they can't like build into or.
Sure, so to the point where they said, look at the departure or the arrival path, it goes right over OB, Ocean Beach. They just had to cut down a bunch of palm trees from Ocean Beach because of the fact that it got in the way of the mandated clearance that needed to be for approaches in. Palm trees.
They come about 100 feet over my house. And yet they had to cut.
You
palm
better
trees
load
on
those
OB.
you better load those ship cannons. Lily.
Can you remind me how far the range goes out?
So it won't be a reminder, it'll be an initial. Here it is right here. The range on a localizer array, those cannons per bend, the complete zone of coverage goes out 10 nautical miles, and it gives a course guidance of 35 degrees to either side. And then beyond 10 out to 18 nautical miles, it's 10 degrees to either side. Okay, so that's the navigation zone. Go ahead, Lily.
No, I was gonna ask you to repeat that.
Yeah, out to 10 nautical miles, it's 35 degrees to either side. So out to 10 nautical miles, 35 degrees to either side. And then out to a total of 18 nautical miles, it's 10 degrees to either side.
Thank you.
That's the localizer array coverage. Chris, you had a question?
Yeah, so for the airlines that are coming into San Diego, they're all, if it's like zero viz, they're all on ILS coming in.
Let me show you.
790.
Yeah, let me show you, because this might make it make more sense. So there's not an ILS for runway 27. So now that we've looked at minimums, you guys will kind of have a grasp on this. So if I look at the approaches into San Diego, and let's not look at RNAV approaches or GPS approaches, let's look only at localizer, which is left to right guidance only, or ILS, which is left and right and up and down guidance. You'll note that there's a localizer, ILS for runway 9 only. ILS for runway 9, localizer for runway 27. No ILS for 27. So if I open up runway 27, we'll see what the minimums are. This is the localizer, no vertical guidance component. It comes down to 680 MDA for localizer, 680 MDA, which is 663 MDH. So the localizer for runway 27, MDA for the loc 27 in that San Diego, MDA is 680. MDH is
663.
663. So that tells me that the airport 667 to 680.
663.
Yeah. Oh, 663. It tells me that the airport's probably 17 feet of elevation. Lo and behold, the airport is 17 feet in elevation. Right? That's the difference between MDH and MDA. Let's look at the ILS now. I'm going to look at Zulu. If you see Yankee and Zulu, like, it means there's two different approaches using the same equipment. But the Zulu one, if you go through the alphabet, Z is at the end, Zulu has the lowest minimums. Yankee would have next to up lowest minimums, so forth. X-ray, X would have next to lower minimums. Zulu has the lowest minimums. So I'm gonna look at the ILS Zulu. And let's look at the minimums on this. Remember I told you a typical category 3 or category 1 ILS brings you down to 200 feet. Lo and behold, this is a typical ILS. It gets you down to 200 feet, but in this case, 217 for the ILS is called DA, decision altitude. DA, decision altitude, I'll explain that in a minute, of 217, or DH is 200, which is typical for a category 1 ILS. MDA on a localizer is minimum descent altitude, meaning you're only allowed to fly down to that altitude, and then at the altitude you cruise across until you reach the missed approach point, whereas you either continue your landing or you go missed. You come down minimum descent altitude. It's the lowest altitude you're allowed to come down to because there is no vertical guidance. A or 1380 is the MDA if you can't identify ZAC glue, i.e. you don't have DME on board, or what's called GPS in lieu of DME. You can actually use GPS as a DME device. DME is like a separate piece of equipment in the aircraft, but if you have GPS, you can utilize that. 1380 or 1140, again, MDA, minimum descent altitude, versus the MDH, minimum descent height. That's AGL, that's MSL, AGL, MSL. Visibility requirements, that's from the cockpit. That one's interesting because there's no way to prove it. They can say that the ATIS didn't say 2 3/4 miles, but that's not the requirement for 91 operations. The requirement for 91 operations is for the pilot to be able to say, I was able to see 2 3/4 miles, even though ATIS didn't say 2 3/4 miles. How do you prove it? You really can't. So you better have different modes of being able to prove that. We'll get into that one later. In the parenthesis, Department of Defense, DOD minima, it doesn't mean anything to us. Categories are ground speed based. We're always going to focus on category A. 90 knots of ground speed or less. Okay, we'll get into more of those categories later when we go through the terms. So that's the profile, minimums, and then the airport diagram, which gives airport elevation. It gives runway information, distances, widths, types of what's called VGSI, visual glide slope indicators. In this case, a PAPI, precision approach path indicator. So you get down to that altitude, hang out at that altitude until you reach a point, which is called the missed approach point, and then you execute the missed. The reason why it's different for an ILS is because ideally, you're following the guidance for the vertical portion, and when you're following the guidance and you get to that altitude, that's when you execute the missed or continue your landing. This one, no guidance, vertical. You're allowed to get down to an altitude and cruise across. This one, vertical guidance, you're following the vertical guidance down, and as you're following that guidance down, once you get to a spot, decision altitude, 217, at that position, which you're 200 feet AGL, you say, can I continue my landing sequence, or am I still in the clouds and do I go missed? Decision altitude versus minimum descent altitude. Good?
Why can't they just use the back course for MI-27?
Because there's no glide slope for the back course.
It's just the localizer.
Yeah. Good? I'll explain that again further. But that's why if you're going to San Diego, if the minimums are lower than 680 and it's VHF only, you're coming in from the west, because from the west has an ILS, from the east does not.
Why is the localizer on the less used run, or like the less used direction?
There's a localizer on both runways. Because remember, the key component,
So why is the glide slope on the one that is less used?
because there's no buildings in the way looking out in that direction. In the other directions, the glide slope wouldn't allow the adequate clearance.
Oh, the minimum are too low to go back.
Good? For vertical guidance.
So
Where's your DA? Is it 1.4 from the airport? 1.4 miles?
No, the DEA is 217.
Right, but at what point, like how far away from the airport?
Oh, I don't know. In this case, it looks like it's 1.4 from the localizer array, 1.4 from the antennas.
Oh, okay.
Good, but you're gonna see that in a second when I show the chart. Cool, questions?
Just a comment, if anyone wants to see like an extreme version of this, there's YouTube videos of Indian Airlines going into Nepal airport, and they have like an extreme version of this because they have to go over the mountains then
Yeah,
pretty much
Super cool.
kamikaze down, yeah.
Where the DME is at 2.6, isn't that the mixed approach point? Or-
No.
No, okay. What is that?
let's not worry about that one yet.
Okay.
It's called the VDP, let's not worry about that one yet. Okay, cool. So back to navates, back to the drawing, which I probably killed, of the ILS. Do I have it on another one? Yes. How does this thing work now? So remember, let's just say there's 4 components. There's lateral guidance, left and right, which is called the localizer. There's vertical guidance up and down, which is called the glide slope. There's distance or range information in the form of marker beacons, which really aren't used, DME or GPS, and then there's an approach lighting system. They're all integrated together. They work together to give what's affectionately known as the ILS, the Instrument Landing System. Good? Here's how it kind of works. So you've got that antenna array that we just showed. That's at the end of the runway. This is the primary course going out this way. This is the back course that is being shown. At the runway threshold, it gives you 700 foot dimensions as full course width for positive guidance, meaning that your needles are working properly. The needles are actually active. And if you're at the very, very edge of active needles, like if you're driving down the highway and you're at the very edge of your lane, you don't get the da-da-da-da-da-da. But if you get into the other lane or you start to get into the other lane, you get the little reflectors, right? You get the dots. Well, you're just on the edge of your lane, that's full scale deflection. At the center line or at the runway threshold here, it's 350 feet to either side. That's the full course. The signal is emanated on a primary VHF frequency. At Montgomery Field, it's 111.95. So then people always ask, where I get this question a lot, well, if the frequency is the same, how does it know if I'm left or right? Right? How does it know? If it's just sending out 111.95, well, how does the needle know if I'm left or right? Because the signal is emanated in 2 different hertzes. 2 different frequency modulations. The definition of hertz, when you're thinking of electrical systems or radio waves, hertz is cycles per second. Okay? So like when you see a TV monitor that's at 700 hertz, it's turning on and off 700 times per second. Versus if you see a TV monitor that's like at 1080 hertz, it's going on and off 1,080 times a second, which is basically more of a steady screen. Okay, cycles per second of turning on and off. Well, the course is emitted in 2 forms of hertz. The right side is emitted at 150 hertz, the left side is emitted at 90 hertz. So it's the same frequency bandwidth, but it's being emanated at 2 different rates. The right side's 90, the left side's 150. So if your airplane's coming in and your radio is hearing a stronger 150 hertz, it means you're more to the right, the needle will swing to the left. And vice versa.
With the needle swings to the left if you're more to the right.
If you're more to the right, the needle swings to the left. Because if I want to be on the center line,
Oh, okay, just
and I'm to the right of the center line, I want to go to the left. Good? So that's how the left-right sequence is involved. 200 feet above the ground would be your typical decision height, 200 AGL for an ILS. Category 1 ILS, 200 feet, yeah.
Where are we getting this information from on the cockpit?
On your needles,
On the needles?
right? So your nav needle, just like you've been following VOR,
Yeah.
same needle.
And it's called nav needle?
Yeah, it's called the nav. Nobody knows what it's called. It's called your CDI. There's the nav radio, but then there's the nav indicator. In this case, you're getting both lateral guidance, left and right, but you're also getting from something down the center of the runway, which emits the vertical, you're also getting glide slope. The glide slope is emanated in the same form, up and down. A typical glide slope for a Category 1 is a 3-degree glide path. So know those numbers. Typical decision height for a Category 1 is 200 feet. Typical glide slope is a 3-degree path. That's normal. Now the glide slope is located, the antenna that emits the signal is located about 1,000 feet down the center line, roughly, and it's offset from the side of the center line. And the glide path is emanated in the same tonnage, being that the 90-foot sequence is, or the 90 hertz sequence is the upper glide path, the 150 is the lower, and your aircraft is listening for the cycles per second of the signal. If it's receiving more of 150, it means you're low, the needle's gonna be up. You need to go up to get it. So ideally, if you've heard the terminology shooting the approach, you want your vertical in the middle, you want your horizontal in the middle, which will end up looking like the crosshairs of optics. Here's your vertical needle, straight up and down. I'm sorry, there's the lateral needle, localizer needle. Here's your vertical needle. That's your glide slope, i.e., if your needles look like this, that's the localizer portion. This is the glide slope portion. You need to go, you want the center, you need to go to the left, and you need to go down to get it. That will be to the right and high. Okay? That's basically how the thing works. It sends out a signal. There's two things that send out a signal, left and right signal, localizer. 90 and 150 hertz, it tells you left or right guidance. The vertical signal, 90 and 150 hertz, it tells you if you're up or down. It cycles you all the way in down to the runway center line. It gives you a distance of 350 feet to either the side of the center line when you're at the threshold. At 200 feet above the ground is typically where your minimums are. That's an ILS. Let's look at it in play. Let's look at the Montgomery Field ILS.
All right.
Oops. ILS is fun. We started class at 1:45.
Yes. Plus
All right.
minus 5.
Here's the ILS of Montgomery. Same format, margin identification, latitude, longitude, coordinate, bottom left corner, amendment date, margin, dates of validity, Julian calendar date that there was a last update, the type. Notice it says ILS or localizer 28 right. This approach plate covers two types of approaches, the ILS or localizer. The reason why it does is this. The ILS turns into a localizer if the vertical component is inoperative. The ILS is a localizer approach if there is no glide slope. This approach plate has both a non-precision approach, localizer only, no vertical guidance, precision approach, ILS, if the lateral and the vertical components are usable. Does that make sense?
So it becomes a what approach?
An ILS, instrument landing system, which has both up and down, left and right.
Right,
If the up and down goes away,
okay.
the up and down portions, you were driving the fuel truck
I was driving the field truck.
and you ran right over the glide slope antenna.
That's not good.
No, the battleship cannons, point no. You drive right over the glide slope antenna, the airplanes no longer have vertical guidance. They can't follow that vertical needle down. The ILS turned into a localizer. Good? Here's how this thing works. The upper section is called the pilot briefing. Localizer, which also gives DME in this case. So that localizer antenna also sends out distance information. That's why it's called loc slant DME. The signal in this case, the name of that antenna is IMYF. The I stands for the instrument system into Montgomery Field. Okay, so that localizer antenna at the end of the runway, again, Ben's battleship cannons, is IMYF. In this case, that signal gives localizer left and right guidance and distance information out. It's 111.95. There's no voice capability. And if you were in a Department of Defense aircraft utilizing UHF frequencies, the conversion is 56Y. You would just dial in 56Y into your equipment. That would be receiving 111.95. The final approach course is 281. In this case, we get runway landing data because it's a precision runway and it gives us all the information for the runway. This approach has a requirement of DME or radar. You gotta have one or the other. Radar services have to be functional, or the aircraft must have DME on board. It gives us some information which we'll go over later. You're circling 10 left, 23, 28 left, not available or not allowed at night. Runway 28 right, helicopter. Oh, I'm not gonna read it anymore, it says helicopter. In-op table does not apply. SILS means straight in ILS for all categories. And then it says for an in-op ALS, approach lighting system, you have to increase stuff.
So in order for you to use that, you would punch in IMYF into your map system and it would ping on a localizer. Am I wrong on that?
Sort of. If you have DME equipment on board, specified DME equipment, right? Like a radio that's made just for DME, you can put 111.95 in it.
No, so you just,
It would give you DME information. If you have a GPS, you could put in IMYF and it'll give all your GPS values as listed down here off of IMYF. Good? So VHF side, 111.95,
Yeah.
DME comes off the localizer. No DME box, no DME dedicated radio. 111.95 for the left and right course. IMYF for GPS in lieu of. You can hit direct to IMYF on your GPS and it'll give you that information. There's also another way to do it. Yeah, you can plug in the approach. And the approach says, yep, you're at Nesty, yep, you're at Penny, yep, you're at Pillows, and so forth. Cool? Johnny?
I don't know if my question is relevant, but does the GPS read the DME information or the localized information off of UHF or?
No, all these numbers are put in, or all the values are put in off of a specific latitude longitude coordinate. And the latitude longitude coordinate would be the position of IMYF. Does that make sense?
Yeah.
Cool. Go for it.
What's the in-op table?
Let's get into that in a bit.
But it's not on the.
Here's what I want you guys to have. I want you guys to have a copy of the Terminal Procedures publication, TERPS, by the book. And here's the reason why, because we're going to go through it, but here's also the reason why. I don't have them for everybody. The in-op table, if you open up the TERPS to the first page, not the cover page, but the first page, it tells you what do you do in the event that there's a piece of equipment that's in-op. i.e., let's go over this one more time. The ILS has, let's just say 4 components. The FAA says it has 3. It has guidance, left and right and up and down. It has approach lighting system. It has a range information, right? John?
Sorry, I was reading this.
So down with that, bro.
Yeah.
The ILS has 4 components.
Yeah.
Localizer, left and right. So if the localizer is in op, right? There's no left and right guidance, there's no approach. Right? You don't get left and right guidance, how are you gonna get into the runway? Number 1. Number 2, if the glide slope is in op, but you still have left and right guidance, the ILS turns into a localizer. The localizer, you can still get in, it just has higher minimums. You just don't have that vertical needle to follow down. So, okay, it's a localizer approach. I don't have, but it just goes higher. You got that one?
Yeah.
So we just covered 4 components. We covered if the localizer is in op, it doesn't matter, there's no approach. That's like what everything's based off, the localizer, left and right guidance. Cool, so we can't have the localizer in op, because if it is in op, we're done. The other component, glide slope. If the glide slope's in op, the ILS turns into a localizer approach. Cool, higher minimums, that's fine. There's 4 components. The next one is the approach lighting system, right? They said lighting, approach lighting system. The in-op table tells us this: if the approach lighting system is in-op, this is what I do, right? And then the last part is range, right? The 4 components. Last one's range. Well, in this case, we have an out because if the range component is inoperative, i.e. IMYF, it said localizer slant DME. If the DME portion's unfunctioning and I don't have a GPS on board, because I could use GPS to suffice, it says radar. SoCal approach controllers would be like, you're now over Nibby, you're now over Nesty, you're 2.1 miles from Penny, you're now over Penny. The FAA in the entire national airspace system under IFR has a plan for contingency on any known or possible anomalies. So they covered you if the glide slope's out, it turns into a localizer. The approach lighting system's out, you increase the minimums. The range information is out. There's another way to do it. Cool?
Cool.
Just like that MSA box. If you lose all your navigation, climb and be safe. Other than that, everything's pretty similar. So, localizer DME, IMYF, final approach course, runway landing, touchdown, TDZE, touchdown zone elevation. Know that one? TDZE, touchdown zone elevation. There's a ton of acronyms. Welcome to IFR. We're going to learn about IFR today. We're going to talk about IAPs where you arrive at the IAF and then you end up being at the FAF, and if you don't get it, you go to the MAP and go miss, but if you lose your navs, you're going to go to the MSA value.
Touchdown zone elevations?
Touchdown zone elevation. Day 1 if I said that? Yeah, we're here to talk about the NAS under IFR. Go
Does
for
that
it.
tell us that the actual runway's got a upslope?
Well, the touchdown zone elevation is, yes, it does. 423 versus airport elevation, yeah. So the primary latitude, longitude coordinates at the airport, the primary itself, is at 427 feet. But the touchdown zone elevation, that's the first 1,000 foot of runway. The elevation on the first 1,000 foot of runway averages to 423. When your wheels touch down, your altimeter should read 423 if your altimeter was perfect. But your altimeter is allowed to be off by 75 feet under IFR. Good? Touchdown zone elevation.
Which is the first 1,000.
First 1,000 feet, touchdown zone. So now, pilot briefing section, again, we'll go over in op. This, remember I talked about the ALS, approach lighting system? You know that acronym. And that's part of the ILS system. It says lighting, approach lighting system, ALS. In this case, the approach lighting system that's designated. There's a bunch of different kinds of approach lighting systems. This one's called a Mauser. M-A-L-S-R. Medium intensity approach lighting system with runway alignment indicator lights. A rail, not a rail, because a rail, R-E-I-L, is runway end identifier lights. Runway alignment indicator lights. So medium intensity approach lighting system with runway alignment indicator lights. The runway alignment indicator lights are affectionately known as the rabbit.
So, say it again, I'm sorry, medium intensity.
Approach lighting system with runway alignment indicator lights. R-A-I-L. Too much?
Huh?
Huh? It's like I'm doing a paradiddle on your brain.
Medium intensity approach lighting system.
Medium intensity approach lighting system with runway. I'll go a little slower for you, Sam.
I'm
lost,
when it
dude.
comes to
Sure,
right
too,
away.
Runway alignment indicator.
There you go.
Lights. Runway.
I'll make sure to put a mark on the there. And is that the ALS or is that its own thing?
The runway alignment indicator lights?
Yeah.
That's part of the Mauser.
So the medium intensity approach lighting system with runway alignment indicator
Yeah, the rails bonus to the ALS.
rails.
It's affectionately known as a rabbit. If you've ever come into a runway and you see that white blinking light that leads all the way up to the runway center line, that is the runway alignment indicator light. It's the rabbit. Yes, sir.
I've seen a video that on top of buildings. That actual, you can do that.
A rail on top of
Like, I've
buildings?
seen a video on like Instagram. It had,
From
like-
on top of
Yeah,
buildings.
it's like it had the blinking, indicating light straight to the center line.
Yeah.
That's an actual.
Yeah, that's it. Watch. I was like, are they trying to guide the airplane onto the building top? I don't want, yeah, I mean, no trophic lateral, no, we don't want that. Who cares? Videos. Fa. Mauser. Try to find anything else. That light there, that's the rail. Is that what you're talking about?
Yeah.
Yeah. And then this is called the array. And that's the approach lighting system. This is the rail leading up to the approach lighting system. It consists of a Mauser. A Mauser is an alpha 5. That's what this says, A5. So a Mauser and alpha 5 is the same thing. An alpha 5 system is a Mauser. The little bowling ball. You are being watched. Let's play a game. You know exactly what I'm talking about, right? And a lot of people in the class don't. What's that? It's from a movie. Let's play a game. The little bowling ball on top of the Alpha 5, that's the rail. The little bowling ball on top of the 5, that's the R component, rail, R-A-I-L. Good? It's just here's a numerical value with the bowling ball being the R. Here's the visual interpretation, and here's the textual format.
Could you repeat that?
Here's the graphical or numerical interpretation with the little bowling ball on top being the rail. Here's the textual, or here's the graphical. This is what it looks like. And then that's the textual format. It's all the same thing. Misapproach procedure, climbing 1100, climbing left turn to 3000 on heading to 270, mission bay vortex radio 326 to Carafin hold. ATIS frequency 26.9, SoCal approach 2435, Montgomery Tower. The big heavy box means it has a tower. The star next to the tower means that's part-time. The airport has pilot controlled lighting. That's the L next to the 19.2. 19.2 is utilized for frequencies runway runway 5, 10 left, 10 right, 23, and 28 left. And then 125.7 is a split frequency for runway 28 right. They're not always split there, but when they do go split, that's what they do, like high traffic volume. 269.4 UHF frequency. If you're in a DoD aircraft, that's what you would put in. Let's not worry about that for civilian aircraft, ground control, and clearance delivery. The approach itself. Biggest, baddest, boldest mark is 4187. I'm gonna get through this rapidly. We're gonna revisit this. This is just an introduction to the ILS. Biggest, boldest, baddest mark is 4187. Out here, the highest threat. The IAF, initial approach fix, starts at Bakel intersection. You come down from Bakel, 4,200 feet on a heading of 196 to get to the intermediate fix of Mibby. Make a right turn at Mibby to intercept the localizer. That's what this barb is. The barb with the shading on the right side means it's the front course. So the barb is the localizer course. The right side's 150, left side's the 90 hertz. Coming in, you're allowed to step down to 3,600 on a course of 281. Once you get to Nesty, allowed to come down to 2,500. Down to Penny, no altitude listed inside Penny. Penny's the final approach fix. The MSA values from inbound courses based off of Mission Bay, 25 nautical miles from 130 to 220, 4,400. From 220 to 340 is 54. From 340 to 130 is 21. That's the plan view. The primary facility or primary nav aid, in this case, there's the darkest box, 111.95, which is the localizer. Coming down the profile view, here's one more kind of addition to, maybe 42 to 36 to Nesty, Nesty down to Penny, final approach fix. That final approach fix is called the what? The Maltese Cross. Is that for a precision or non-precision approach?
None.
That's for the localizer. So the Maltese Cross listed at Penny is for the final approach fix for the localizer course. Remember, this is 2 approach plates. But if I happen to also have the glide slope, I'd have the full ILS. The final approach fix for the ILS is here. That 2,500 with that arrow. That arrow denotes something called glide slope intercept. 2,500 feet with that arrow denotes glide slope intercept. Meaning this, if you're at 2,500 feet at Penny intersection, your glide slope should be level, and that's where you can start to follow it down. Glide slope intercept. So if someone were to ask me, hey, where's the final approach fix for the ILS on this? I would say at 2,500 feet, which happens to happen at Penny intersection. If someone said, hey, where's the final approach fix for the localizer, the non-precision approach, I would say the Maltese Cross at Penny. Go for it.
So once you hit 2,500 at Penny,
You're following the glide slope down.
at 500 feet. 3 degrees. At 500 feet, descent.
At 90 knots ground speed, it's approximately 500 feet per minute. Yeah. Good. Hence the reason in the lab,
Yeah.
I had you guys find
500.
500 feet per minute. Yep. So 2,500 feet glide slope intercept is the final approach fix, and then you come down on the glide slope. Note, 1380 has a star. The star means it's for the localizer only. The 1380 is a step down fix for the localizer. If you have full glide slope, all you're doing is following the glide slope all the way down to your decision altitude of 673, where you execute your decision. It's the altitude where you make the decision. Can I continue to land, or do I execute the misapproach procedure? The glide slope's kind of like if I pointed a laser up at a 3-degree angle, I intercepted it at 2,500 feet away from the airport, and I just kept that laser right in front of me all the way down. And then when I follow that laser all the way down to 673, I'm at my minimums. And I say, hey, I look up. Can I see the airport environment, threshold lights, centerline lights, runway end identifier lights, approach lighting system? Runway environment? Yeah, I can. Okay, I'm gonna continue my landing. Or I follow the laser all the way down and I look up at 673 and say, can I see the airport center line, the airport engine lights, the runway end identifier lights, the the runway environment, threshold markings, numbers, whatever it is, approach lighting system? Nope, I'm still in the clouds. Boom, missed approach procedure. I made the decision at that altitude. The localizer, MDA, minimum descent altitude, you come down to 1380, go across until you're at 3.6, cool. Now, I'm gonna come down to 820, and I'm gonna fly all the way across at 820 to my missed approach point. That's 0.7, it's the last DME listed. That's my missed approach point for the localizer, and then I make a decision. We'll get into that one later. That's an introduction into the ILS. Vertical and horizontal guidance, distance information, approach lighting system. It comes down to a DA, not an MDA. A DA is found on the glide slope. Good? We're gonna take a break. We're gonna forget about this because we're gonna revisit it. That was just a preview. After the break, we're gonna come back and we're gonna go over the midterm. Ben?
Oh no, I was just excited.
Questions? Any questions at all on this? Sam?
Can you go over flight levels?
So if you're at 2, 8, 9, or 2, and you climb out, you hit 18,000 feet, circling to land. What are the minimums?
1380.
Be careful with this one.
What was the question?
A category Bravo aircraft circling to land. What are the minimums?
Sure, too.
Alan?
If they can identify Zeklu, it's 1140.
So give me both. So 1380 and 2 3/4 miles. Both those. So the minimums, the height is 1380, the visibility is 2 3/4, right? But if you could identify Zeklu, then you're allowed to come down to 1140 and 2 3/4. Identify both. Good?
And that, the distance, the 2 3/4 is straight up and subjective.
2 3/4 is what's considered to be flight visibility as seen from the cockpit or the pilot. That one's kind of tough, just due to the fact that how can they prove you wrong?
Right.
Right? Now, other operations will say the ATIS or the ASOS, right? The reporting equipment on the facility has to report that visibility in order to fly the approach. But for a Part 91 operation, general aviation, right? Yeah, I was able to see 2 3/4 miles. Sure, they're reporting 30 feet. I saw 2 3/4 miles, tell me I'm wrong. You can't. Go for it.
But if you're getting close and you look at the ASOS and it's reporting like super low minimums, are you not gonna just pick somewhere else to? Or are you gonna keep going until you?
Good decision.
Yeah.
Yeah, that's probably what you should do, right? Inbound on a heading at 240. What's the MSA value? 7,700 feet. Everyone sees that? MSA inbound. What's the highest topographic point on the chart? 4187. Good. For 2-6 right, what type of lighting is found? Airport diagram.
High intensity.
Rail and tarmac.
First there's a rail, 2-6 right rail, but then don't quit there, look through all of them. There's a rail and a hurl. What's a hurl? What people do when they fly with me. No, high intensity runway light. Does the tower ever close?
Yes.
Why?
Because that's
Perfect.
That's
Be careful with this next question. Where is the FAF located and what is the intersection name? You could look here because it has a Maltese cross, Finley intersection, right? But where it's located, don't just give me 4.2 Pogey. Because if you just give me 4.2 Pogey, I can go anywhere on that circle. Tell me either this, Finley intersection, which is at 4.2 Pogey on the 336 radial. Go for it.
If you say Hoagie 4.2 on a course of 156,
Inbound on a course 156, sure.
that's still good, okay?
I would prefer it on the
Radial.
336 radial.
Okay.
Or you can tell me it's on the 336 radial off of Pogey and the 103 radial off of Mission Bay. That's the cross intersection. Is the airport lighting pilot control?
Yes.
What are the dates of validity for this? It'll change for the midterm. You guys got it. Does Pogey VOR, I could either have it from here, right? Or up here. Does it have voice capabilities? What's so funny?
I have no idea.
John asked.
No, wait, tell me why again.
See the underline?
Okay.
See the underline? If you look on AirNav, let me show you another way. See how it says L, I don't know if you can see it. See how it says L Vortac W? Here, that says Vortac W. The W means without voice, no voice capability. Same thing that the underline means here, the underline is the W, without voice. Sam?
So if you have a frequency for SoCal approach, and you have ground tower, and you have ground control nodes and stuff, what would be the reason you need to talk to Mission Bay?
You wouldn't. The only reason you would need to talk through a VOR would be to flight service station, San Diego radio, to open or close a flight plan.
Oh, so if you're en route.
Yeah, to get an updated weather briefing, to get updates on TFRs, to file a PIREP. Go for it.
How would you do that if they have no voice there?
Can't. That's the point.
So what do you get with the voice? Is that just what you said, those examples?
Yeah, let me show you. Like here, Oceanside, it's up here. See how it says 122.1R? And then under it says San Diego? That means San Diego radio. San Diego radio is San Diego's flight service station. They receive you on 122.1, but they can't transmit back to you on 122.1. They'll transmit back to you through the VOR. See it, Chris?
Right, yeah.
So you would transmit on 22.1, you would listen on 15.3. And for those reasons. Hey, I need to close my flight plan. Under IFR, if you land at a towered airport and the tower is functioning, they're awake, they're operational, they'll automatically close your flight plan the moment your wheels touch the ground. But if you land at a non-towered airport, nobody's there. If you don't call in and cancel or close your flight plan, within a half hour, search and rescue operations begin.
Right.
And trust me when I tell you this, they're not happy people if you forget to close your flight plan. They'll be like, really? we initiated a SAR. Just give us a call. Good?
Is Flight Service Station a separate entity to TRACON and
Yep.
and Central?
Yep.
So
TRACON's radar.
So Flight Service Station, they just have a building somewhere, or are they on an airport? Or
They're hanging out somewhere.
they're just hanging out?
Yeah, it used to be that flight service stations were co-located on airports, and you would walk into the airport, the operations building, and go to flight service, and be like, hey, can I get a weather briefing? And they'd print out all these charts, and, you know, on an old dot matrix printer, and like with the little rollers on the side.
Yeah.
And then you would have to look at like surface analysis charts, radar returns, right? And it was actually printed.
Yeah.
Now we have capability of Aviation Weather Center. Or electronic flight plan.
So 1-800 weather brief.
Yep.
Is that's Flight Service Station?
That's flight service station that goes through a company called Leidos,
Yeah.
which was formerly Lockheed Martin. So it's private.
Oh, okay. So when you phone that number, you're going through the same people that you get through to if you call 1 to 2.1.
You got it.
San Diego radio.
Yep,
Okay.
flight service station.
Is there a fine that goes with not
No.
closing?
No.
Still don't do it.
Do you get for
Yeah.
with the search and rescue fee?
Who said it?
Does you get with the search and rescue fees? Do you get hit with the search and rescue fee?
No. If they do launch search and rescue, you could be liable for the costs imposed. But that's if they launch assets, right? Spend time looking for you and you're hanging out in your cabin having hot cocoa, right? Then you might get hit by it. You are liable. But if they just begin search and rescue, that's starting the initiation of phone calls and cool? Yeah.
Part 91, general aviation. What if I'm putting in an IFR plan and I'm flying, using an ILS, can I fly zero viz to that runway?
No.
That's only like our airline industry, or?
Well, if it's zero viz, if it's considered 0-0, let me show you a 0-0 approach. And let me show you what it reads. So let me specify that actually in a little bit better method. If you're flying Part 91, yeah, I guess you could do it. If you're like 91 in an aircraft that's certificated to do it, because you could be flying Part 91 in a 747, right? Like, who's the band, Motley Crue, or who's the band that's guy is a monster?
Or that actor, what's he called?
You know what I'm talking about.
Trump Force One?
Yes.
That'd be Part 91, are you saying?
Yeah.
Fuck, alright.
Wait, Trump? That flies Part 91?
Air Force One is not Part 91. Air Force One's a special operation. But let me show you an example. For a Category 3 or a Category 2 approach. So if I look up ILSs, note it says Cat 2, Cat 3 on these ones right here. Here, Cat 2, Cat 3. If I look at those, not Travolta, it's a rock band. Notice what it says at the bottom on the minimum section. Special air crew and aircraft certification required. So if you're flying in a Part 91 operation, like you and your rock band own a 737, and you've got air crew and aircraft certifications to fly that, then yeah, Part 91. You can do it. But I think what you're referencing, Part 91, is a small light civil aircraft.
That's what I'm saying, can anybody get in a small light
No.
and have the ILS?
No.
Okay, so
No.
you will hit the missed approach and you will have to find another place to land.
Yeah, if you're below minimums. Yeah. Cool. Those were all the questions for the VOR. Kill the GoPro.